Howdy class. Today we're going to be continuing our handout on matrix operations. This one's going to focus on a system of equations where the number is two equations and two variables, such as you see right here. Okay, so where A and B are both numbers, constant numbers. And we want these letters to be different. Oh, wrong one. Even more the wrong one. Okay. So we're going to go ahead and replace this A with a C, and we're going to replace this B with a D. That way they're all unique numbers. R1 and R2 again are just numbers. So first off, let's go ahead and write this in a matrix format. So we've got matrix A x plus by, and then cx plus dy equals R1, R2. This is one way to write it. You can also write it like so. A, B, C, D. And then just our X matrix is X and Y. And then that equals R1, R2. Okay. And so notice that, when you multiply these two matrices, right, you multiply this guy, and then you go down, right? A times the X, B times the Y, as we've shown before. And then the same with the next one, CX plus DY. Okay, and that gets you back to where you were. So we can shorthand all this by calling this matrix A, this matrix X, and we'll call the resultant matrix matrix R. Okay, so over here, if you multiply matrix A times X, it's exactly what I was showing over here. Let's go ahead and just go through the process. AB, CD, and the matrix X is simply the row matrix XY. Okay? So let's go ahead and write this or multiply this through. Again, A times B, X times Y. And so the A goes to the X, B goes to the Y. So when we write it out, we get AX plus BY. And then when you do the other one, right, when you're over here, this guy is going to here. So you have, and again, yellow to yellow, blue to blue. So we have CX plus DY. Good, and so of course this equals the resultant matrix, which are those two guys there, right? AX plus BY equals R1, CX plus DY equals R2. So now let's look at how to solve for the system, right? We've got AX equals R. How do you solve for X? Now you might think, oh, well, you just divide by a number, right? X equals R divided by A. You might think that that's a proper way to solve something, but it is illegal to divide by a matrix. And by illegal, I mean you can't do it. Stating it just simply means it's an operation that makes no sense. How would you divide one matrix by another? Like, what is the operators that would dictate that? It does not make sense. So again, you cannot divide by a matrix. So circle this and write illegal. You cannot divide by a matrix. Now what you can do is you can multiply by the inverse, right? Something times its inverse will typically equal 1, or some kind of identity, right? Some kind of multiplicative identity. The multiplicative identity for multiplication is 1, right? Because you can multiply anything you want by 1 and it stays the same. It's the identity for multiplication. So let's consider this. The number a is any number except for 0. What is the inverse of a? So you're multiplying by a to the negative 1, right? Multiplicative inverse, a is just a number. Well, you divide by it, right? 1 divided by a equals 1, which again is the multiplicative identity. So I want to talk to you a little bit about the identity matrix. And I've already kind of given you a hint about the identity matrix over here. So we have the identity for a number, which is 1. So the identity for 1, you can just write that as 1, right? Kind of think of that as 1 by 1, or scalar, if you will. Now an identity for a 2 by 2 is 1 0, 1 0 0 1. Note the 1s along the diagonal. Note the 0s everywhere else. The identity for a 3 by 3, and we'll go ahead and just write this, the identity for a 2 by 2. The identity for a 3 by 3 matrix, same pattern, 1 1 1, 0 0 zeros everywhere else, right? 1s along the diagonal, 0s everywhere else. Alright, you can do larger ones, right? Oops, do that in red. Larger ones, I of a 4 by 4, 1 2 3 4, and then you just have zeros everywhere else. Oftentimes people will just write it like that, where it's assumed that the zeros are off. For right now, anytime you're writing an identity matrix, we're going to be keeping them kind of small anyways. I want you to go ahead and write in all the zeros just to kind of hammer home the point. Yeah, just like so. And again, note the 1s along the diagonal and 0s everywhere else. So the identity matrix, well, basically, if you multiply something by its any matrix, if you multiply by its inverse, will get you the identity. If you multiply a matrix by the identity, doesn't matter the size of the matrix, as long as you multiply it by the corresponding identity matrix, you'll get the thing itself. That's what makes it the identity. And so note, when you're multiplying, by particular dimensions, say a is a 1 by 2, so you must multiply the identity, right? Identities are always square, and so this will get you a, again, 1 by 2, following the rules, right? The 2's match. If you have something different, say a of a 5 by 6, well then your identity matrix should be a 6 by 6, right, following that second number. And when you multiply through, a will be 5 by 6. Okay, so that's the identity matrix. So let's look into finding the inverse of a 2 by 2 matrix. So if A equals A, little a, right, B, CD. So we want to find the inverse, and so we've got a nice formula to find the inverse. So our inverse will simply equal alright, so we got 1 over something called the determinant, which we'll write here as D. And we multiply, we're going to rearrange the matrix to look like this. dA, right, the D and the A swap places. And then we put a negative around the, we'll call it the reverse diagonal. So again, the reverse diagonal. So that'd be, put a negative along right there, and then you swap places of those two guys right there. Alright, so that's how you rearrange the matrix. So what is D? D is the determinant. What is the determinant? So first off, a couple of notation, right? You can write determinant also, you put an absolute value around the matrix A, or not an absolute value, but it's the same symbol. Also written as determinant det of A. But ultimately, what does it equal? It equals AD minus BC. So note the AD, write the numbers along the diagonal, and then BC, the numbers on the anti-diagonal or reverse diagonal. Like so. AD minus BC. That's it. That's the determinant of a 2 by 2 matrix. So we're going to work a quick example real fast. And in this example, we're just going to find the inverse of a matrix. We'll just make this one a quick and simple, easy one. We'll define matrix A as being 1, 2, 3, 4. That way you can easily see where each of these guys are going. First, we find the determinant. And so again, the determinant is going to be the elements along the diagonal, and subtract the ones along the reverse diagonal. So along the diagonal, we've got, always state your formula when you're working these. And just as a side note, when you're working your homework, make sure you are writing in some kind of notebook as if you're going to physically turn that notebook into me. You're not going to physically turn that notebook into me, but it will be great practice if you do. I know it takes more effort to do this, but if you do write everything out as you're working the homework, you will get more out of this class than someone who does not. And when you're working these in your notebook, make sure that you are always writing the formula every time you use them. Alright, so we have our determinant set up. Alright, AD, well, little a is 1, D is 4, minus BC, so 2 and 3. Simple enough. So let's go ahead and multiply these through. So this is 4 minus 6, which of course is negative 2. And now let's set up our inverse. Our inverse is well, let me go ahead and just write the formula out. 1 over D, dA minus CB. So 1 over negative 2, and then we just do all the rearrangements. And essentially that is our inverse matrix. Let's go ahead and distribute that scalar quantity right here of a negative 1/2. And so it becomes negative 2, positive 1, 3/2, and 1/2. And that's it. That's our identity matrix. Our inverse matrix. Let's go ahead and run a quick check equation on this. And so the check is simply A times the inverse. And so that is 1, 2, 3, 4. And then the inverse, negative 2, positive 1, 3/2, and 1/2. Now, if this all works, we get the identity matrix as the result. Let me go ahead and give myself a little more space here because I want to check it both ways. Let's do a quick zoom in. There we go. All right. So remember, matrix multiplication, right? 1, 2 times negative 2, 3/2. So this will give us negative 2 plus 3/2. Times 2. Which will get us 1. So just so you can kind of see what's going on here, this is right, negative 2 plus 3, right? 2 times 3/2. All right, so next one, we're going to multiply once again this row times this column. And so that's going to be, all right, ladies and gentlemen, I apologize. I left off a negative sign right here. I just noticed that. So make sure you include that. So let's go back to here. Put the negative sign where it's supposed to go. Okay. So let's go ahead and run through this calculation. 1 times 1 is 1. 2 times negative 1/2 is negative 1. 1 minus 1 is 0, which is what we want. Okay, so next one, 3 times 4, and we multiply by that column there. So 3 and 4, let's go ahead and run these. Have a little side calculation here. And we will have negative 6 plus 6, which gets you 0, just what we want. And then for the next one, right, once again this row, and then we go by that column there. And this will be 3 plus negative 4 times negative 1/2, which is 2. 3 minus 2 is 1, and we put the 1 right there. And that is the 2 by 2 identity matrix, which is precisely what we wanted. Now, just to show you that it works both ways, we're going to go ahead and do it the other direction, a negative 1, a. In general, you cannot reverse the order of multiplication, but for inverses you can. So let's go ahead and run through this one. So we're putting the inverse matrix down first. Negative 2, 1, 3/2, and negative 1/2. And, got ahead of myself. Do matrix A, 1, 2, 3, 4. All right, and let's run through this. Right, so we've got negative, let me go ahead and circle them. Right, this one, oops. Yeah, 1 goes there, okay. This one, right, times that one. And so let's write out the calculation. We have negative 2 plus 3. That is 1. Put the 1 there. Okay, so we're done with that one. And then we do the next guy, which is -2. Write this column here, this row here, and then this column right there. And then let's write out our calculation. This is -4 plus 4. And note that grants you a 0 right where you want it. And now we do the bottom row. Okay. And so we've got here 3/2 minus 3/2. That's 0, just as you would want it to be. And then finally, the very last check calculation, right? Again, this row, that column. 3/2, 3 minus 2, which gets you 1, which is precisely what we want right there. So again, that is the identity of a 2x2. So as you can see, our formula works. So let's move on to some more interesting equations here. Again, there's the bottom AB. Change those into a C and a D. There we go. And so let's look at this then. In our matrix format, right, we've got our matrix A, which is A, B, C, D, times our XY matrix, which equals our resultant matrix, right? So again, this matrix right here, that's our matrix A, and we're going to use that to find our inverse. But we already know how to find the inverse of this, right? It's just 1 over the determinant times just like that, right? So no biggie. But again, we want to find AX equals R. So what are we to do? So we have to multiply both sides by the inverse. Now keep in mind, order matters. So if you multiply it on the left side, you absolutely must multiply the matrix by the left side on both sides of the equation, right? If you write it like this, then that is wrong, because it doesn't match what's going on there. So we want it to look like this. Okay. Note that if you wrote, it's got to be on both sides. So if I wrote a to the -1 and then a to the -1, if you did it that way, well, yes, you haven't changed the equality, right? The equal sign is still going to work, but note that you're going to multiply x times a to the -1, and that's also not going to work. So in order for this to work, it has to be like this. A to the -1 must be on the left-hand side on both of these. Now when you do this, note that on the left-hand side we have the identity matrix times x equals A inverse times R. Over here, and identity times any matrix will just be the matrix itself. So x equals the inverse matrix times R, which is 1 over D times dA, well, dA in this order and here, and let's go ahead and write out our resultant matrix, R1 and R2. And then you just multiply it through from there, and you have your result for x. Minus b times R2. And then we have down here negative CR1 plus AR2. And of course the determinant is defined above. I'll go ahead and rewrite that, right? It's simply AD minus BC. Okay, and there you go. So the 1 over D, you multiply that by, this guy, and then this guy as well. And that's your answer. That's the general layout of how to solve these. So let's go ahead and work the following example. So again, we want this to be in the format AX equals some resultant. And so let's set this up. Our A matrix is 2, 4, 2, 3. And our X matrix again is, X and Y. Our resultant matrix is 0 and 1. So first we got to figure out, well, what is the inverse matrix? So A inverse, again, 1 over D multiplied by dA negative C negative B. Okay, so putting all this together, we've got 6 minus 8. And then over here, just simply rearranging 3 and the 2, and then the negative 2, negative 4. All right, 6 minus 8, that's going to be negative 1/2. And the rest of the matrix, of course, stays the same. Okay, so there is our inverse. Do we want to multiply that negative 1/2 through? Yes, we do. Let's go ahead and do that. So this will become negative 3/2, positive 2, positive 1, negative 1. Okay, take a moment. Always want to double check your work. Okay, that looks good to me. And let's move forward. So again, this guy up here, we can express this as A negative 1 times A times X equals A to the negative 1 times R, where again, order counts. So we're making sure to keep the order the same. And so we note that these two guys multiplied together gets us simply the identity matrix. And so X equals A inverse times R. So let's come down here. X equals negative 3/2, 2, 1, negative 1. And then a resultant 0 and 1. Okay, so this should be a nice quick calculation. Don't forget rows to columns, right? Rows to columns. And so negative 3/2 times 0, that's 0. 1 times 2 is 2. And so the next one, negative 1. Okay, that's our answer. So let's go ahead and double check this one. You can check this by directly plugging in, of course. All right, and so for the top equation, right, this becomes 2, negative 1. 2 times 2 is 4. Minus 4, that is 0. That is indeed what we have. And do the same here. 4 minus 3 is indeed positive 1, so it does check out. The other way you can check it is to simply multiply the matrix A times X to see if you get the resultant, right? Because that's how it should be. And so A, once again, 2, 4, 2, 3. And then the matrix X we found to be 2 and negative 1. And so as a reminder, 2 and 4 go this way. And just remember, this is a 2 by 2, and matrix X is a 2 by 1. So we are expecting a 2 by 1 resultant. And so when we run through this calculation, right, it is 4 minus 4, which is 0. That's what we're expecting. Let's do it like that. And then the next one, right, the 2 and 3 are going to be multiplying into that column. And so we have 4 minus 3, which gets us the value of 1. That is the matrix R. It does check out. So again, that's how you can check things out if you just want to keep things in a matrix format. Okay, and that looks like that is everything for this handout. I do encourage you to work this same example after you've done it by hand. Put everything in Excel and go through these exact same operations that we went through here. We're going to go ahead and look how to find the inverse of other matrices, and just look at 3 by 3. So basically, when you want to find the inverse of a matrix A, you're going to create, an augmented matrix that looks like this. And we'll just be doing this off of scratch paper here. A and I. All right, where I is the identity matrix, A is the matrix you're trying to find the inverse of. And so we'll just set this up. I'll come up with one that shouldn't be too hard. So let's find the inverse of this matrix A. This will be our example. And so again, note that this is a 3 by 3. So if we want to find the inverse, this is what we do. We set the matrix up like this, which is simply a matter of going 2, 2, 4, and then, over here, 0, 1, 2, and what do we do right here? We write the inverse matrix. Just like that. And so we are going to undergo a process of matrix operations. I'll come back over here. We want to do it to where we reverse. That's that, right? We want the inverse over here, and then we end up with whatever the inverse matrix is going to be on the right. So we're going to be doing a series of row operations to make that happen. Okay, so again, trying to make the left hand the inverse. So first thing we do is we're going to be doing a series of pivots, right? So we want to first make this one. We want to have a 1 right there. So we're going to go ahead and say, well, 1/2 R1. And so that's 1, 1, 2, pretty easy one right there. And of course, 1/2, 0, 0. Everything else is the same. Then 0, 0, 1. Just like that. Okay. So the next thing is, again, we're going to be pivoting off of this guy here. and we want to use him to eliminate that element right there. And so this is simply a matter of replacing row 2 with R2 minus row 1. So note that the top stays the same. And it is the middle row that is changing. So we've got 1 minus 1 right there. That is 0, which is what we wanted. And now we're doing these two rows. 2 minus 1, so that's a 1, which puts us right where we wanted. That's nice. And then we've got this one here, 3 minus 2, which is also a 1. Now don't forget, we got to do these guys here, right? So 0 minus a half, so negative 1/2 here. One minus 0, so 1 goes here. And then over here, of course, 0 minus 0, and so a 0 in that one. All right, so far, so good. So now we're going to be pivoting off of this guy here, and we're going to use that guy to eliminate that guy right there. So we're going to do the matrix operation, replacing row 3 with row 3 minus row 2. Okay, so note that the top two rows are going to stay the same, so just go ahead and rewrite them. 1, 1, 2, 0, 1, 1. Then of course 1/2, 0, 0, 1, 0. Okay. All right, now let's do our operation. Zero minus 0, of course, is 0. One minus 1 is going to be 0. That's what we were after in the first place. 2 minus 1 is 1. All right, so that worked out nicely. If it was something other than 1, we would just have to multiply that row by whatever number you see here, but it's already a 1. I'm sorry, I said multiply. You need to divide that row by everything the number you see there, but it's already a 1. That's what we want, so we're good. So we keep going on down the row. 0 minus a negative 1/2. So it's positive 1/2. Right here. 0 minus 1. So negative 1. And then the last one, 1 minus 0, so it's 1. So note that we almost have the identity matrix. We just gonna have to eliminate those guys right there. So first thing we do is we are going to be using this guy as our pivot element, and we're going to use him to get rid of this guy and this guy. So we're going to do two operations on the step, so let's record them. We're going to replace row 1 with row 1 minus 2 row 2. And then we're going to replace row 3. And we're going to replace row 2 with row 2 minus row 3. So we write this as, again, being very careful, because we are doing two operations, easy to make a mistake here. So we have row 2 minus row 3. 0 minus 0, of course, that is 0. So you write that here. And then we're doing this one here. 1 minus 0, so that is 1. And then look here. 1 minus 1, of course, that is 0 as well, which is just what we want. Let's go ahead and throw our augment line down. And let's go ahead, while we're at it, go ahead and write in this third row, since that guy is not going to change. And let's work through the last bit of this row operation. Alright, so negative 1 half minus 1 half is negative 1. 1 minus negative 1, of course, is positive 2. And then 0 minus negative 1, 0 minus 1 is 1. Negative 1. Okay. Alright, so now for the next row operation, right? Doing those. 1 minus 0 is 1. And then over here, 1 minus 0 is going to be 1. And then over here, right, we've got 2 minus 1, which is, 2 minus 2 times 1, right? Because, reminder, we are multiplying by that 2. We don't want to forget that. So that is going to be 0, which is what we were looking for all along. Alright, so let's look at the next bit right there. 1 half minus 1 half, 2 times 1 half, sorry, which is going to get us negative 1 half there. 0 minus 2 times negative 1. It's going to get us positive 2. And then finally, 0 plus negative 2 times 1, and that's going to get us a negative 2. Okay, so we are just one row operation away. Right, we want to get rid of this guy here, and we're going to be pivoting off of this guy here. So the row operation we need to perform is to replace row 1 with row 1 minus row 2. Alright, so the bottom two rows stay the same, so let's copy those down like so. And let's perform that row operation. R1 minus row 2. Alright, so let's go ahead and look at this, right? 1 minus 0, well, that is just 1, which is what we want. The next one, 1 minus 1, awesome, 0. The next one, 0 minus 0. So of course that's 0. Once again, we just did those two right there. Negative 1 half minus negative 1 gets us a positive 1 half. Alright, and then of course we've got, let's go ahead and get rid of that one there. 2 minus 2, which is going to be 0. And then we have these last one, negative 2 minus negative 1. That's going to get us negative 1. Okay. And so our inverse matrix is this one I am highlighting in green right there. Right? That is our inverse matrix. So let's write that down. Minus 2 plus 2. So that is 1 right there. We go to the next one. And so we've got 0 plus 4 minus 4. That's 0. Go to the next one. Negative 2 minus 2 plus 4, that will also be 0. Beautiful so far. Alright, so now we're moving on to the next element row. So we'll be going off of this row right here and going into there. Alright, so we have 1/2 minus 2 plus 3/2. That will get you 0. Make sure you're checking these calculations. Don't just take my word for it. Next element, right? 0 plus 4 minus 3. 4 minus 3, that's 1. Right where we want the 1 to be. And then we have our last one of the row. Right, so negative 1, negative 1, 1 on the column side. So this turns into negative 1 minus 2 plus 3. Well, that all equals 0, which is just what we want. So now we are on the last row. So we begin multiplying through. So we've got negative 1 minus half of 2. Well, that's going to be 0. This one here, we have 2 minus 2, which is 0. And then the last one, negative 1 plus 2, well, that will simply be 1. And that is the identity matrix, just as we had hoped it would be. Okay, so this is, in a nutshell, how you find the inverse if you don't have a 2x2. This does work with a 2x2 matrix as well. We can work this in Excel, like with row operations, just like we did when we were trying to simply solve a matrix. You can use this trick to find an inverse as well. So that is all for today. And if you have any questions, make sure to email me. Otherwise, have a great day.